Astronomy is the story of origins on the grandest scale there is. We see the births of stars, of planets, of galaxies, and we can also watch them grow and change. One of the clearest ways we have of viewing these phenomena is through radio telescopes. In 2022, radio astronomers made a lot of exciting discoveries. Here are highlights of just a few of them. The Tarantula Nebula is an immense complex of gas and dust, the birthplace of hundreds of thousands of stars. The most luminous among them blast out millions of times the energy the Sun does. How does that affect the material around them? Astronomers used NRAO's ALMA, the Atacama Large Millimeter Submillimeter Array, to look at carbon monoxide gas in the tarantula, which forms long filaments and traces the effects of star formation. As expected, the gas is quite turbulent, moving around every which way, especially in clouds close to the brightest stars in the nebula, where a lot of energy is pumped into the material. However, there was also a surprise. Stars are still forming even in the most turbulent areas, their gravity able to overcome that maelstrom and draw in material so they can grow. It's almost as if the universe wants to make stars, even in unlikely environments. It also likes to make planets, including ones that are nothing like what we see in our solar system. GJ896 is a nearby binary star, two small and faint red dwarfs orbiting each other. Astronomers observed the stars with the extremely high resolution of the Very Long Baseline Array, or VLBA. This allowed them to precisely determine the star's motions in 3D and revealed a surprise, a planet twice the mass of Jupiter orbiting one of the stars every 284 days. An even bigger surprise is that the planet's orbit is tipped way over relative to the orbit of the stars around each other. It's not clear why. Did the gravity of the other star or an unseen planet throw the big planet's orbit off? Or did it somehow form that way in violation of what we know about planet formation? VLBA observations are helping astronomers solve this strange planetary mystery. Sometimes cosmic origins spring from cosmic deaths. Pulsars are rapidly spinning neutron stars, superdense objects created when the core of a massive star collapses after it explodes as a supernova. Using the Carl G. Jansky Very Large Array, or VLA, astronomers discovered the pulsar VT 1137-0337. It's one of the youngest pulsars ever seen, only between 14 and 80 years old. It wasn't seen in a 1998 VLA survey, but has shown up in several observations since. Material from the supernova explosion may have initially blocked our view, but thinned enough as it expanded to let the pulsar's light through. This happens very soon after the explosion, indicating the pulsar's youth. This makes the pulsar one of the very youngest ever seen, born in death, and only known to us because we scan the skies in radio waves. Supermassive black holes exist in the center of every large galaxy, and grow huge by merging with other big black holes when their host galaxies themselves collide. So we expect to see some merging galaxies with their black holes closing in on each other. However, that's rare. UGC 4211 is one such pair of merging galaxies. Observations from a large number of telescopes, including ALMA, show that at the center of this cosmic train wreck are two black holes, each about 100 million times the mass of our Sun, and they're only about 750 light-years apart, extremely close on a galactic scale. They'll likely merge to form a much bigger black hole, though not for hundreds of millions of years. ALMA may reveal more of these black hole pairs, an important step in the cosmic origin of both large galaxies and their huge central monsters. From planets to black holes, from the solar neighborhood to distant galaxies, the cosmos hosts the birth of an amazing array of objects, and with NRAO and its fleet of telescopes, how they come to be is getting clearer.